in this experiment 2, you will do a digital input, output, and timer on Atmega 32. Okay, so this experiment 2, you need to write your program in a C program, which is in this experiment 2, what you need to do is you need to know how to initialize your I/O input output ports, as well as how to program your timer. Okay, in order to create a delay. Okay, so semua dapat tengok saya punya what we call it PDF ni, lab sheet. Semua nampak
Nampak?
Ya, dapat.
Okay, so I think all of your group already submitted the preliminary report. Okay, so sebab I just check in the Google Classroom. Okay, sudah ada 2 yang hantar. Okay, I hope both of the group sudah submit lah. Okay, so now we are going to see the what we call here the procedure that involved in experiment 2. Okay, so this is the objective. Okay, which is you're going to initialize your input-output port. Okay, by using a C programming, and then to calculate and programming delay using a timer. Okay, I assume that this one was not covered yet in your class. Betul tak? Tak masuk lagi kan? Sebab kita masih lagi in assembly language, correct?
Ya, belum masuk.
Okay, so and then next you are going to simulate the output of firmware by using the AVR IDE simulator. Okay, previously, okay, in this previous semester we do all this thing here in Gotronic board. Okay, which is you do all the connection, sambungan, wiring semua dekat board. But now untuk semester ni, okay, you need to do by simulation lah. Okay, by using a simulator. Okay, and then to add additional code to upgrade your operation firmware. Okay, so this is the objective that for this experiment 2. Okay, and then this is the equipment list as well as a reference. Okay, so then we go to the procedures lah. Okay, so you have how many procedures? Okay, so this is the procedure. Okay, first, what you're going to do is you need to open your project by using your AVR Studio. So any changes, okay, if you're going to do some modification or if you're going to add some programming to your program, you need to do by using the AVR Studio. Okay, every time you modify your program, you need to compile that program. Okay, please make sure that lepas kamu dah tambah kamu punya program, your firmware, okay, make sure that you compile. Okay, build and compile. Okay, kalau tidak nanti when you burn it to your AVR simulator, what happen is dia akan ambil the previous old punya file. Okay, so once you dah open your project by using the AVR Studio, okay, step number 2 is you need to wire up your peripherals on AVR simulator IDE. Okay, so make sure that all the connection is correct lah. Okay, so in this what we call it, in this experiment 2, okay, the tools that you're going to do is the component that you're going to use is the LEDs. Okay, kamu akan guna 8 by LEDs board. Okay, ada 8 bit LEDs. Okay, which is you're going to connect to your port C. Okay, so kalau you refer to this figure 1.1, okay, so this is your LED. Okay, so this is your LED, which is this LED here, you connect to your port C. Okay, so kamu ada 8 LED, all of these 8 LED kamu akan sambung kepada ports. Okay, the first LED port C kosong, and then port C1, port C2 until port C7. Okay, and then next, okay, you need to use the 7-segment LED display. Okay, which is this 7 segment here, yang ni kamu akan connected to your port B. Okay, so this is your port B, 7-segment display. So make sure that the connection is correct lah. Okay, A should be connected to port B0, yang this LED B connected to port B1, and then the last one here, the H, okay, this one here, the decimal point here connected to your port B7. Okay, so yang 7 segment display ni kena sambung betul lah, kena all the correction should be correct lah. Okay, kalau tidak nanti you get the funny characters. Okay, and then next you need to have a microprocessor view. Okay, for the kat sini, in which kat sini nanti you will, okay, kat sini, okay, in this side here, kamu akan control the switches by press this toggle button here. Okay, nanti saya akan tunjuk. Okay, once you are wiring, okay, all the connections, then what you're going to do is the third step, okay, to load your Atmel Studio project to your AVR Studio IDE. Okay, so macam mana nak buat? Okay, so you load your project yang kamu dah tulis, okay, to your AVR Simulator IDE by select file and then go to load program and locate your hex file, then click OK. Okay, contoh lah. Okay, so I going to open my AVR Simulator IDE. Okay, kalau kamu tengok kat sini, dia bagi tahu kat sini. Okay, since this is a evolution punya mode, so dia ada dia punya ni lah, duration lah. Okay, so yang ni kalau kamu tengok ni, kamu boleh guna 30 kali saja. Okay, you able to start the program 30 times, which is one session will end in 60 minutes. Means that one session is 60 minutes. So 30 kali darab dengan 60 minit, you have ada berapa tu? 1800 minutes. Okay, so kamu ada dua lagi lab, okay, which is lab 2 and lab 3 yang akan guna AVR Studio IDE. So make sure that tak exceeded this evaluation mode lah, dia punya duration. Alright, so you just click yes. Okay, dia duduk belah sana ya. Okay, so I need to bring it here kat sini. Okay, and this is my LED. And this is my 7 segment. Okay, so this is the AVR Simulator IDE. Okay, macam mana kita nak pilih kita punya component ni, the LED, the 7 segment. Okay, you just go to tools, okay, and then pilih lah from this list here. Okay, so you have nak ambil LED, so just click this 8 by LED box. Okay, if you're going to use the 7 segment display, so just click this one, and for the microcontroller view, okay, just ambil this one here, microcontroller view. Okay, so ada 1, 2, 3 je. Ada 3 components that you need to select from this tools here. Okay, next, we are going to burn the program that we write in the AVR Studio to what we call here, to this simulator. So macam mana nak buat? You go to this file. Okay, and then I always clear the memory. Okay, saya selalu clearkan memory dulu, and then load program. Okay, next, what you're going to do is you need to carilah you punya file tadi, you letak kat mana. Okay, so make sure that the file is in .hex file. Okay, hex. Okay, the extension is hex file. Okay, so and then you double click this one. So you already link the program to this AVR Simulator IDE. Okay, the next step is, okay, once you dah ni, you need to confirm the microcontroller used is Atmega 32 and CPU frequency is 1 MHz. Okay, so macam mana nak buat? Okay, you need to do the setting lah, like as shown in this figure 1.2. Okay, we go back to our AVR simulator. Okay, so kat sini. Okay, you see here, this is a microcontroller. Okay, here, Atmega 32. Okay, you can pilih. Okay, you click that one, you can pilih which chip that you're going to use. So in this case here, we're going to use the Atmega 32. Okay, and then you pilih select. And what about the clock frequency? Sama juga lah. Okay, you click this one here, and then just write down the frequency speed. Okay, so just tulis kat situ 1.0 MHz and click Okay, so you already pilih the Atmega 32 chip and with the clock frequency of 1 megahertz. Okay, next. Okay, you are going to programming the what we call the lab 2 experiment 1 project to AVR simulator. So how to we going to burn or program, okay, the C program that we written in AVR Studio to AVR simulator by, okay, this one here you can done by select the simulation and press start. Okay, so you will see the simulator will start running and give output at 7 segment display. Okay, so macam ni. Ada saya punya, oh saya dah tutup tadi ya saya punya ni. Okay, tools, microcontroller view. Okay, so I go to simulation here, just press start. Okay, so you see here, the 7 segment display will display a character lah kat situ. Okay, so this is the starting of your program. And then, if the simulation is too slow, okay, if you find out tiba-tiba you punya simulation sangat slow untuk display this character here dekat sini, okay, any changes here is too slow, what you need to do is you go to this rate here and pilih lah. Either it's fast, extremely fast, okay, and it become faster. Okay, the simulator will become faster. Okay, if it's too slow lah. Kalau it's normal, so just pilih normal saja. Okay, because the delay between the first character to the second character kat sini, it depends on the delay that you will create. If the delay is 1 second, and then it will display 1 second lah for each character. Okay. So next, what you're going to do is, okay, you're going to report your result as required in table 1. Okay, make sure that the PA0 and PA7 to PA7 switches are not pressed. Okay, so macam mana nak tahu dia press ke tak? Okay, this one is pressed. Why? This is your PA0 until PA7 kat sini. Okay, so this PA0 sampai PA7, all of these switches are pressed. So what you're going to do is, you tutup dulu. Okay, by pressing this button here. Okay, so sekarang ni it is in default mode lah. Okay, which is all of the switches are not pressed. Okay, and then you go to your table 1. Where is your table 1? Okay, so this is your table 1A. Okay, so what happened? When no push button press, okay, you tulis lah apa yang berlaku. Okay, you describe what is it any display at your 7 segment panel, and then describe the pattern generated at the LED panel and content of your pin A. Macam mana kita nak dapat content of pin A? Okay, so this is a 7 segment display. If dia tunjuk any change, what we call here, any character, you just write down lah apa character yang dia display kat sini. And what about your LED? So since the LED is off, you just katalah the LED is off. And what is the content of pin A? Macam mana kita nak dapat? Okay, you go to this general purpose working and I/O register kat sini. Okay, from your AVR simulator, and you need to find out your pin A. Okay, scroll sampai bawah and cari. Okay, so this is your pin A, yang ni. Okay, by right, your pin A is 0 lah because you not press any switches kat sini. Okay, let's say like if you press one switch kat sini, so what happen? You see this one here, the pin A kat sini telah berubah. The value is now 0, 1. Okay, if you press 3 switches, well, so what happen? You see here, ada 3 switch you dah press. Okay, which is the pin A value is 0, 7. So you just write down the pin A value according to this table kat sini. Okay, so first is no push button press, and then when you press your SW0, switch 1, switch 2, and switch 3. Okay, switch 0 is for connected to ni lah, PA0, switch 1, PA1, switch 2, PA2, and switch 3 is at PA3. Okay, make sure that every time you press these switches, the rest of the switch must turn off lah. Okay, only one switch press at one time. Okay, sampai sini ada question tak? Ada soalan tak? Up until here.
Doktor.
Ya. Yeah.
Kalau yang 7 segment tu dia macam dia tak cukup apa, macam contoh 3 dia hilang satu kepala ke atas tu.
3 hilang satu kepala ke atas. Tengok kamu punya connection kat sini. Betul ke tak?
Oh. Okay.
Okay, so you need to make sure that all the connection kat sini correct lah. Okay, sebab yang ni kita punya 7 segment display kita ada 8 LED. Okay, kalau kamu tengok A is your least significant bit, while H is your most significant bit. So make sure that A connected to PB0, while H connected to PB7. Okay, and then make sure that you use the common NAND lah. Okay, because why? If you use the inverted level, okay, contoh lah. Boleh tak? Okay, contoh I stop dulu simulation. Okay, let's say like I wrongly choose the, okay, I use the common cathode, which is kalau common cathode is positive. Okay, if I use the common NAND, what happen is when I send 0, then the LED will turn on. So kalau kamu tengok kat sini, nampak dia punya value dah berubah. Okay, make sure that the connection is correct and you going to use the common, in this case here common cathode lah, sebab common cathode you send one to your 7 segment display, then the LED will turn on. If you send 0, the LED will turn off. Okay. Start again my simulator.
Doctor.
Yes, saya.
Just want to ask, I try to stimulate already my 8 LED board. Ada light lah, tapi untuk segment LED dia like langsung dah ada display. Kenapa?
Semua LED tak display. Okay, because sekarang ni you ada press any switches tak?
Semua switch dia on lah dekat pin A sini.
Okay, because if we refer to our what we call here, okay, sekejap ya, saya bawa ini ke sini. Okay, if we refer to this program, okay, you see this program here. Okay, port C is connected to our LED, betul tak? While port B is connected to your 7 segment. Okay, this one ya.
Yeah.
Okay, you see here this under this while loop. Okay, this one, if pin A sama dengan 0001, baru dia akan display your LED. And when pin A sama dengan this number, then the second LED, the second pattern of LED will be display. Else, if you put any switches, if you pilih dua switches ataupun semua switch off, what happen is dia akan display yang kat ni je, yang this one je. Okay, let's you select only switch 0 je yang you press. The rest you turn off. What happen to your LED? Nyala tak?
Maksudnya I hanya select yang switch PA kosong kan?
PA kosong.
Tak nyala juga.
Tak nyala juga. Betul tak LED you connected to port C? Port C. All the LED connected to port C. Is it correct or not?
Oh, the LED connect to port C, betul?
Betul ya? Kalau betul should be nyala lah. Okay, tak apa, nanti kita akan you share you punya what you call it, you share you punya screen. Okay, nanti kita akan tengok.
Boleh.
Alright, so once you dah done this part here, okay, so the next procedure is, okay, you're going to write a program to generate a delay. Okay, so by using a timer 0 normal mode, calculate the TCNT value to generate 200 millisecond delay. So you generate a 300 millisecond delay. Show the calculation clearly and write the delay. Okay, so you need to write down your delay subroutines. Okay, delay 200 using timer 0 function. Okay, and then after that, what you're going to do, after you calculate all the delays here, 200 millisecond delay, and you write down the programming, next, we are going to implementing the complete function of this experiment 2. Okay, which is you need to modify. Okay, you need to modify. Okay, this program here. Okay, so that whenever you press SW and SW3 switches, okay, so when you press SW2 and SW switches, it will display this LED pattern. Okay, so this pattern will be displayed when you press SW2, and this pattern will be displayed when you press SW3. Okay, bear in mind that the time delay for each blinking is 200 milliseconds. So you need to use the program that you write in this step number 5. Okay, and last but not least, when no switches is pressed, okay, make sure that you display this code lah. Okay, SKEE 3732. Okay, and then followed by dash your group code. Okay, so if you group 13, so just write down 513. If you group 14, SKEE 3732 dash 514. And then this one here, okay, the time delay for each blinking is 400 millisecond. Okay, so you need to modify lah, so that because this one is 200 and then this is 400, so macam mana nak buat this character here will be displayed to 7 segment, which is the time delay for each blinking is 400 millisecond. Okay, so that is for what we call here for today's punya lab lah. Okay, and then once you done untuk yang modify punya parts, okay, so you need to fill in this table. Okay, this is calculation and this is a delay timer function coding. And then once you done everything, the modified part, so you can put all the modification inside here, and then I will, okay, you will demo to me lah, either it's working or not. Okay, nanti saya akan tick sama ada dia berjaya atau tidak. Okay. So now, any question? Ada soalan tak?
Doktor.
Ya. Yeah.
Untuk yang 7 segment tu yang kan ada yang ski 3732 tu kan?
Ya. Yeah.
Doktor nak dia maksudnya dia memula S, lepas tu K, lepas tu E macam tu lah?
Ya, betul. Saya nak dekat satu ni je. Tak semua. Saya nak dekat satu, kan kamu ada 1, 2, 3, 4, 7 display. Okay, so the SKEE 3732 tu akan display dekat satu 7 segment display je. Dia akan display macam ni lah. Lebih kurang macam this one lah. This one kan ditunjuk. Okay, sekejap ya. Okay, kalau saya off yang ni. Kamu tengok yang ni kan ditunjuk SKE. See? SKE. Tapi lajulah yang ni. Okay, because the delay is too fast, this one. Okay. So sekarang ni saya nak kamu tunjukkan SKEE 3732 and then your group code.
Untuk yang tu, kan saya buat coding dekat else tu kan? Dia tunjuk SKE je. Yang lain-lain tu dia tak jadi. Kenapa doktor?
Yang ni sebab kamu kena modify ni. This one you need to modify. Okay, table yang dua ni kamu kena tambah. By right sekarang ni apa yang ditunjuk SKE saja. So you need to tambah lagi.
Ya, maksudnya saya dah letak coding dia. Dah tambah huruf E lagi satu SKE 3732.
Okay.
Lepas tu,
tapi tak
tak keluar, tak nyala.
Okay. kan saya bagi tahu tadi. Okay, every time you do the modification, okay, every time you add the code, you need to compile.
Compile.
Okay, once you dah compile, you stop dulu kamu punya simulator and load again the program. Okay, you need to load again the hex file. Ambil semula hex file yang baru, yang terkini, yang after you compile.
Oh, okay.
Kalau tidak nanti dia akan ambil yang masih lagi pakai yang lama. Which is the hex file tadi dia tak updated. Okay, if you not compiled, means that the hex file, it will use the old hex file, not the updated hex file. Okay, make sure that every time you modify and you add a certain coding, you need to compile. Compile dulu.
Okay.
So I will, kalau tak ada any other question, ada soalan lain tak? Kalau tak ada soalan, saya nak bahagikan kamu kepada group. Okay, I want to make a breakout session sekarang ni.
Lagi satu tak?
Ya, saya.